Good morning, everyone. This is O'Shane again, and today we're going to be looking at simplifying simple radicals. Okay, now this is another very, very important topic in your bridge to geometry journey. Reason being, when you're doing geometry, you're going to be doing a lot of topics that will require you or have you end up with radicals. And most of the time you will be required to simplify the radical instead of using your calculator to do it. For example, you might get something that looks like the square root of 20. And what you guys will do is probably put it in your calculator and get this 4.472, right? Now, in geometry, they are not going to want the 4.472 because this is still an approximated or rounded value. What they're going to want is the simplified version, which is going to be 2 root 5. And what we're going to do is we're going to learn how to simplify radicals today. We might have done it a little bit before, but I'm going to use this opportunity to run through a few things. So the first thing I'm going to do is explain to you the concept of a perfect square. So if you can see here, I have some notes here, and I'm gonna uh, pause the video. You can pause the video, make sure you write this down. So what I have written for you here is your first 20 perfect squares. To learn how to simplify radicals properly, you're gonna wanna learn these. That's the first step. So your first perfect square is 1 because 1 squared is equal to 1. Your second perfect squared is 4 because 2 squared is equal to 4. Then 9, then 16, etc. So what's happening is that your perfect squares are 1, 4, 9, 16, 25, 36. These are perfect squares because they are the product of two integers squared, right? Sorry about that. The product of the same two integers squared. So for example, 121 is a perfect squared because it's a product of 11 times 11, which is the same as 11 squared, which gives us 121, all right? Similarly, there is a relationship between perfect squares, right, and the numbers that were squared to get them there. That relationship is that the square root, this is a square root symbol, of the perfect squared is going to give us back the number that we squared. And the reason for that is that the opposite of a squared is actually a square root. So we're gonna look at that here. I have some notes on that further down, so no need to rush it. So right now, what I want you guys to do for me is to write down your first 20 perfect squares. After that, you have 49, 64, 81, 100. And similarly, the square root of 100 is 10. The square root of 81 is 9, right? And this is a relationship that you must prioritize understanding, okay? The next are 121, 144, 169, 196, 225, 256, 289, 324, 361, and 400. These are your first 20 perfect squares. And the square root of the perfect squares give us back the number that we squared. Okay, so I'm just gonna zoom out for you guys here. All right, and take a look at it. Um, Write it down. So I'm gonna pause for just about 5 seconds so the screen is still. Okay, awesome. So these are your perfect squares. So the relationship, right, that I have here as some notes. So what I have here is how we say it. So this is 6 squared, written as 6 squared, right? And that is 6 times 6, and that gives us 36. Pretty straightforward. And I've written here that 6 squared means that we're multiplying 6 by itself, right? So 7 squared means we're multiplying 7 by itself, right? So 7 by 7 is going to be 49. So 49 is a perfect squared, right? Because 7 multiplied by 7 to get us there. Similarly, the square root of 36 is equal to 6. This is what I was explaining before. 36 is also 6 squared. And so the square root of 36, check this out, the square root of 36 can also be rewritten as the square root of 6 squared. And what's happening is that in mathematics, a square root and a square cancel each other out, leaving us with the number. That's why the answer is 6, right? So I have it here. A square and a square root cancel each other out. Important. So similarly, the square root of 49 is 7. Why is that the case? Because 49 can be rewritten as 7 squared, which means that this square root will cancel this square, leaving us with 7. Similarly, 81, the square root of it, can be rewritten as 9 squared, which means that the square root cancels the square. Okay? So all of that is just really important here. I'm just going to backtrack a few things. Um, and this is important for us to focus on. It will all add up later, promise. Now, this is what I want you guys to understand. And you can write this down for me, please. When simplifying radicals, it is important to remember all your perfect squares. That's these, we just wrote them down. It's important to remember all your perfect squares. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225, 256, 289, 324, 361, 400. These are your first 20 perfect squares. It's important to remember them, okay? So when simplifying radicals, it is important to remember your perfect squares and the relationship it has to square roots. So critical. All right, I'm building here. So, for example, this is just the technique and steps. Given a radical to simplify, so let's say I say, hey, simplify the square root of 27. These are your techniques. All right. Now, the first step is to divide 27 by perfect squares, starting with 4 until you find one that goes into 27 without leaving a remainder. This is important. This is your first step in simplifying radicals, right? So let me say that again. We're going to divide 27 by perfect squares. Remember, the first couple of them are 1, 4, 9, 16, 25, 36, 49, etc. Right? Now, obviously, 27 is smaller than all of these. So this is a pretty simple one because we're only testing either 4, 9, let's humor it, 16 and 25, right? So we're going to divide 27 by perfect squares. And what I recognized was this. When I divide 27 by 4, I got 6.75, right? This does not work because it must go into it without leaving a remainder. Then the next one I tried was 27 divided by 9, and I got 3. This works. It works because 9 goes into 27, 9 goes into 27 3 times without leaving a remainder. That's what we're looking for. And so what happens is step 2, Now we simplify. Because we have identified that with 27, we are working with 9 and 3, where 9 is the perfect square. What we're going to do is we're going to break up 27 into the product of 9 and 3 by writing it as the square root of 9 and the square root of 3. And what happens after that is the one that is the perfect square, we find the square root of that because we know it's going to come out of the square root. So what we have is the square root of 9, which is the same as the square root of 3 squared. See that? And the square root of 3. And what happens with the square root of 3 squared? The square cancels the square root, leaving us with 3. It comes out of the root. And we're left with this term here, which is square root of 3. This is the simplified radical for square root of 27. Okay? Please repeat this as many times as necessary. Like, go back to the video, make sure that we're focusing on this, right? Now, I'm going to do more examples later on when I touch on my worksheet. Now, going to the next level, all right? So I have here the square root of 72, right? And what I want to do is I want to touch on this because this is kind of like where the topic gets tricky for people, right? So the square root of 72. Here's a question. What perfect squares divide evenly into 72? And I say try it, okay? So let's try it. 72 divided by 4, right, goes 18. So 4 works. 72, what's the next one after 4? 9, there you go. 72 divided by 9 is what? 8. You see the drift? We have a problem. Or not really a problem, but now we have two perfect squares that work. We have 4 and we have 9, right? So it would be 4 and 18, 9 and 8. But let's see how many go into 72. Let's go. What's next after 9? 16. There you go. 16 does not work. 72. Let's stay consistent here. 72 divided by 16 gives me 4.5. That doesn't work. All right. Let's keep going. What's after 16? 25. There you go. So 72. Let me just move this a little bit. Okay. Let's go again. 72 divided by 25. Obviously, we know this doesn't work, right? But let's still go. 72 divided by 25 gives me 2.88. So we know that doesn't work, right? 70, what's after 25? 36, there you go. 72 divided by 36 is what? I'm sure you can get this one. What is it? There you go, it's 2. So uh, technically, or obviously, you realize that if I pass the halfway point of the number, then I can stop there. So we've recognized that 36 also works, okay? Now, we have 3 perfect squares that divide evenly into 72. The 3 perfect squares are 4, 9, and 36. Here's the question. Which one gets the most out of the radical? You can answer that. Well, the one that gets the most out of the radical is 36, right? And this is the most important part of the lesson because technically 4 still works, but I'd end up with the square root of 4 and the square root of 18, which would give me, what's the square root of 4, guys? It's 2. So I'd end up with 2 root 18. Similarly, if I use 9, square root of 9 and the square root of 8, I'd end up with, what's the square root of 9? 3 root 8. And if I use 36, and I'd use 30 square root of 36, square root of 2, and I end up with what? 6 root 2, because the square root of 36 is 6. The one that gets the most out of the radical is this one, because I'm left with a smaller or smallest number left in the radical, right? So this is what we say. Here's the rule. When simplifying radicals, find the largest, this is it here, the largest perfect square factor of the number, the largest perfect square factor. So we had 4, we had 9, we had 36. The largest perfect square factor is 36. Very, very important. Now, what happens is, I just wanted to add a side note in my notes. The following radicals can always be simplified further. Why I'm saying this? What happens here is that I could have simplified the square root of 18 further by saying, I'm going to leave this 2 here, and I'm saying, what two numbers multiply to give me 18? Or what perfect square goes into 18? Well, the perfect square that goes into 18 would be 9, and 9 times what gives me 18? 2. So then this one would have been 2 multiplied by the square root of 9, which is 3, multiplied by the square root of 2, which gives me 6 root 2. You see that? So can you realize that I got to 6 root 2 faster by using the bigger perfect square? Let's do this one. 3. What two perfect squares give me, sorry, what perfect square goes into 8 without leaving a remainder? Well, 4 and 2. So square root of 4, square root of 2. So this becomes 3 times, and what's the square root of 4? 2 root 2. This would be what? 6 root 2. So we're getting to the answer eventually, but if you don't use the largest perfect square, then we're going to end up with radicals that can be simplified further. So here is it. These are a few radicals that can be simplified further. If you end up with 12, then it means that there is a bigger perfect square that you can use. If you end up with 18, 20, 24, even 8, as you could see here. Because these numbers have another perfect square factor, right? Like 18 has 9 and 2, and 9 is a perfect squared. It means that there is a bigger perfect squared. And the only way you're going to master this is if you keep going. Okay? So, what I want to say is correct doesn't always mean simplified. For the square root of 72, using 4 root 18 is mathematically correct. Remember that. It is just not the simplest form. The goal is to end with the radical that cannot be simplified any further. This is the most important part of the lesson. All right. I kind of sped through it. I'm going to share this worksheet, well, my notes with you guys. I'm going to just download this as a PDF and send it to you. And then let's do some practice. Okay. Awesome. Okay. So now let's look at a few examples together, right? And as you can see, I have written some big numbers and well, this is a smaller number, bigger numbers, right? So let's go through this process together and see where this journey takes us on. So remember, I'm simplifying the square root of 80, right? So what I need to do is I need to divide 80 by my perfect squares. So let's divide 80 by 4. All right. I get 20. So this works. But remember, I need to find the biggest perfect square. So I'm going to keep going. 80 divided by 9 doesn't work. Okay. 80 divided, let me write it out. Doesn't work. What's the best way to write that? Does not work. All right. Let's try it that way. 80 divided by 16. Right? That works. That gives us 5. 80 divided by 25 does not work. I'm just gonna say does not work, right? So we don't waste our time. 80 divided by 36 does not work, okay? Remember, we're looking for leaving no remainder. Let me just get rid of that. Because 36 that we just divided by 36, the next perfect square would be 49. We know it wouldn't work because 49 is greater than half of 80 because half of 80 is 40. So technically, we have two perfect squares. And as we discussed before, with these two perfect squares being 4, and 16, we're going to use the biggest perfect square. Okay? So let me just write this out for you guys here so that it's there. So 80 divided by 4, right? And we know that that worked. That gave us 20. And 80 divided by 16, that worked, right? And that gave us 5. But we're going to use this one because this is a perfect square. That's the largest one. Okay? So with that being said, let's set it out. This will become the square root of 16 multiplied by the square root of 5. And what did we say before? The square root of 16 is the square root of 4 squared. That's multiplied by the square root of 5. And the square root of 4 squared is just 4. And this is square root of 5. And this is your answer. Okay? That's all that it is. 4, this is how we say it. 4 root 5. 4 root 5. Right? Let's look at this one. Bigger number. Is it scary? Let's see. Let's start small. 768 divided by 4, that works. That gives us 192. As you can see, we got to keep going, okay? Let's go again. 768 divided by 9 does not work, okay? 768 divided by 16, that works. So right now, because we've gotten to 16, then we can eliminate this one. You follow? All right. 768 divided by 25 does not work. 768 divided by 36 does not work. 768 divided by 49 does not work. 768 divided by 64, that works. 768 divided by 64 gives us 12. So now we can take out that. Now here's the trick, right? In the last video, or not last video, I recorded 2 videos and put them together. In the video where I was just explaining to you guys when we're breaking it down, because this is 12, what's the hint? I can still keep going because 12 can be broken down further, right? So let's keep going. 768 divided by 81 does not work. 768 divided by after it's 100, but you know that's not gonna work. Then 768 divided by 121 does not work. 768 divided by 144 does not work. 768 divided by 169 does not work. 768 divided by 196 does not work. 768 divided by, what's the next one after 196? 225 does not work. So which one is it? 768 divided by 256 works, right? 768 divided by 256, that's equal to 3. I gave this question because I want you to understand that as long as you are going through your perfect squares, because this one, square root of 256, is literally 16. So you almost made it all the way through your first 20 before you got to this one. So a lot of persons would stop here and think, let's stop here because the square root of 64 is 8. And you feel like, I've got my answer. No. The fact that we got 12 right here means that we can keep going. There is a bigger perfect square. So what we do is we head up here and we say square root of 768 would be the square root of 256, square root of 3. And the square root of 256 is the square root of 16 squared, square root of 3. And this will be equal to 16 square root 3. Some persons are going to be tempted to find the square root of 16 and write 4 root 3. Please never, ever, 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 ever do that. Why am I saying that? Because I have taken it out of the square root and gotten 16. That's where it ends, right? Please remember that. So this was a great question, just showing you how we go through the process. Let's do one more together. Ooh, a nice one. Okay, so let us go. So 1, 1,584 divided by 4. That works. That gives us 396. Obviously, let's keep going. 1,584 divided by 9. That works as well. 1,500. That gives me 176. I can then eliminate that one. Okay. 1,584 divided by 16. That also works. This one's a nice one. That gives me 99. Let's keep going. 1,584 divided by 25. That doesn't work. I'm sure we can see that. 1,584 divided by 36 also works. That gives me 44. I hope you can see the pattern here, but let's keep going. 1,584 divided by 49 does not work. 1,584 divided by 64 does not work. 1,584 divided by 81 does not work. 1,584 divided by 100 obviously does not work. 1,584 divided by 121 does not work. 1,584 divided by 144, that gives us 11. So we take out that one, and this is the one that we're going to use. And I did 3 together with you so that you could see the pattern and how I'm doing it. And so now, what I'm going to do is, oh, well, I'll say this. The reason why we know we can stop is that 11 can't go any further, right? We can always tell if you can go further. So let's look. These numbers are big, so you can assume it could go further. 99, obviously, 9 can go into here, so we know that 99 could be broken down further. Similarly, 44, 4 can go into it. So once we can identify that a perfect square can still go into the remainder, then we have to keep going. So this is going to be the square root of 144 multiplied by the square root of 11. And the square root of 144 is 12, root 11. Well, let's stick to what I've been doing. It's the square root of 12 squared, which is 11. Because 144 is the same as 12 squared, okay? And what ends up happening is that this will become 12 root 11. And this is your answer. Okay, guys? Awesome. All right. I think it's time for you to try a few on your own. Let me know how it goes.